This is John Allison from Arkansas Ames. I'm here to work the FRQ released FRQ from AP Precalculus Exam 2025 number 2. I do these calls, and I do this so that I can get a feel for how my students feel when they open the exam and immediately have to begin solving it. And also want students and teachers to see that it's okay to make mistakes. There may be mistakes on here because it's the first time I've looked at the problem. I've not seen it before I turn on. When you see it on the video is when I first see the problem. So let's go ahead and get started. I'm going to switch this over to my document camera and start the video. And once we get it where you can see what I'm doing, I will go to the problem. See if we can auto focus. Page. That's about as good as it's going to get, I guess. Okay. All right. So now I'm going to go to the problem. All right. I'm looking at, I don't post the problems on here because College Board considers it a violation of their copyright policy. So I will include in the description of the video links where you can go to the College Board website and view the problem. So here we go with number 2. All right. We have a musician released a new song on streaming service. Streaming service online. Okay. And we know what all that is. Several months later, the musician began using an app at time t equals 0 that counts the total number of plays for the song since its release. A play is a single streaming song. The table gives the total number of plays in thousands for selected times t months after the musician began using the app. At t equals 0, the total number of plays was 25,000. Okay. T equals 0, plays 25,000, T equals 2, total number of plays 30,000, T equals 4, the total number of plays was 34,000. So months after the app. And total number of plays since release in thousands. If I was doing this on the exam, I would not copy this table, but because you're watching a video, I want to get 0, 2, and 4. I've got 25,000, 30,000, and 34,000. That's the table we're looking at. We're doing number 2. We go to A. Oh, we also have this function, d of t equals a times t squared plus b times t plus c, where d of t is the total number of plays in thousands for the song since its release, and t is the number of months after the musician began using the app. So A1 says using the given data, write 3 equations that can be used to find the values for constants a, b, and c in the expression for d of t. So when d of t is 25, t is 0. So that would be, I'm going to go ahead and put this in here even though I don't need it. We're going to solve the system with a matrix. We would need those zeros. When d of t is 30, t is 2, so that's going to be a times 2 squared plus b times 2 plus c. And when d of t is 34, t is 4. Go ahead and clean this up. So this equals c. This equals 4a plus 2b plus c. And this equals 16a plus 4b plus c. Those are my 3 equations that we can use to solve. Find the values for a, b, and c as decimal approximations. Okay, I'm going to go ahead and plug in the 25 for c in the bottom 2 equations. I tell you what, I'm going to do this with a matrix. I'll teach my kids to solve equations. Gonna do it, the matrix or not. Now let's solve it out correctly. 25 is C, we know that. So we're going to put in this equation. I'm going to rewrite this in order. 4A plus 2B plus 25 equals 30. And 16A plus 4B plus 25 equals 34. So I'm going to go ahead and subtract 25 from both sides in both equations. 4A plus 2B equals 5, and 16A plus 4B equals 9. I'm going to multiply the top equation by 2, or negative 2, sorry, and get negative 8 minus 4B equals negative 10. And that's going to give me, that's going to give me on the bottom 16A plus 4B equals 9. So now I'm going to add the two equations together, and I'm going to get 8A equals, and this is negative 1. So A equals negative 1/8. Now I'm going to plug that into the second equation, and along with C, and I'm going to get 4 times negative 1/8 plus 2B plus 25 equals 30. Subtract my 25 again. Multiply my 4 times my negative 1/8, and I'm going to get negative 1/2. And then I'm going to get plus 2B equals 5. So that's 10 halves. As it's going to be 2B equals 11 halves. 10 halves plus 1/2 equals 11 halves. That's 2B. So I divide by 2, I get B equals 11/4. So as decimal approximations, A equals negative 0.125. B equals 11/4. It's going to be 2.75. And C is going to equal 25.0. We could do a regression here. Let's go ahead and do a regression. This is still on the calculator part. We're going to enter these 3 points in a list. The stat, edit. I'm going to put 0, 2, and 4 in list 1. And then I'm going to, in L2, put 25, 30, and 34. May have been the easiest way to do this to start with. I'm going to do stat again, second quit. Stat again, calculate. We're going to do quadratic regression because we're looking for a quadratic here. We got this one, let's do. We can go ahead and store the required equation. And that's what we got. We got the same thing. Okay, so that's A1. Let's do A2. Go back to my problem. Oh, we did fine. That's A2. Let's do B1. Use the given data to find the average rate of change of the total number of plays for the song in thousands per month from T equals 0 to T equals 4. So the average rate of change is going to be D of 4. Well, let's just put the values in the table. 34 minus 25, total number of plays in thousands, minus 4 minus the total number of plays in thousands, 0. And then over 4 minus 0. We're given this as a decimal approximation. So this is going to be 9/4, which equals 2.25. And that is in thousands per month. That's the average rate of change. B2, to use the average rate of change found in part B1 to estimate the total number of plays for the song in thousands for t equals 1.51. So we can say that if we start at t equals 0, we could say that we're not sure what to call this. I'm just going to say d of t approximately equal to. We're going to use this. This is the y value, okay? And we're going to use the rate of change, which was 2.25, times the t value, or t, minus the known t value of 0 when the number was 25,000. And so that's going to be d of t is approximately equal to 2.25t plus 25. And so we're going to approximate this. D of 1.5 is approximately 2.25 times 1.5 plus 25. And may as well use a calculator here so we don't make a mistake. 2.25 times 1.5, 3.375 plus 25, which is 28.375. And let's look for units here. Show what we're going to, the rate of change estimate the total number of plays for the song in thousands per t equals 1.5 months. This is just the total number of plays. 1,000 plays. Okay. So B3. A of t represents an estimate of the total number of plays for the song in thousands using the average rate of change found in part B. So by for A at 1.5, find part B2. It can be shown that A of 1.5, A at 1.5 is less than D of 1.5. Explain why in general A of t, or A sub t, is less than D of t for all t. A sub t is the estimate, where 0 less than t is less than 4. Because A is negative, it tells us we should include a reference to the graph of D. So the graph of D is going to be an upside down parabola. Let's go ahead and look at the graph of D. We have 0, 25. We have 2, 30. And we have 4, 34. And so that graph is going to be a downward opening parabola. And so when we look at the graph, and we'll say the graph of D of D is concave down. On the interval from 0 to 4. Therefore, the secant line connecting 0.25 and 4.34 is entirely below the graph of d of t on that interval, not inclusive. Since the secant line, because we have to include a reference to d, the graph of d in its relationship to a sub t. Since the graph of a sub t is the graph of the secant line, a sub t less than d of t on that interval, 0 less than t less than 4. Okay, part C. Quadratic function model D has exactly one absolute minimum or one absolute maximum. Minimum or maximum can be used to determine a domain restriction for D based on the context of the problem. Explain how that minimum or maximum can be used to determine the boundary for the domain of D. All right. So let's look at C. All right. The absolute maximum is the total number of plays since the song's release. Since the play cannot be taken away, the number of plays is always increasing or constant. At time t1, where d of t1 is the maximum, the model suggests there will be no more plays of the song. Making a reasonable domain for d of t, the interval 0 less than t less than or equal to t less than or equal to t1. And that should be a sufficient explanation, I believe. We'll see when the rubric comes out, since we don't really know. But that is my first attempt at a solution. for question number 2 on the 2025 pre-calculus exam.